So, hey everybody, thanks so much for taking the time to kind of look through our presentation. I'm Prakash, I'm one of the co-founders of Harbor. So what I'm gonna do in this talk is four things. I'm gonna talk through what Harbor is. I'm gonna talk through its use cases. I'm gonna go talk through who can actually use it. And then finally, the main part of the presentation is essentially a demo that we put together so that you guys can kind of get a sense of what the developer experience is like when you're working with Harbor. So let's get started. So quite simply, like, what is Harbor, right? Harbor is an easy way to declare and spin up production-ready testnets of varying complexity. So suppose you were building an application that worked with Axelar. You have your own kind of smart contracts. You're also integrating with Compound. Well, with Harbor, you would simply declare, give me a testnet with Axelar, Compound, my contracts, and these chains, and a few minutes later, it would exist. Similarly, if you were working on something really simple, let's say just a singular EVM chain with your protocol and let's say Uniswap, declare it, and a few minutes later, it will exist. Now, these environments can be kind of long-running, so think you're building like a production-ready kind of staging environment, right? Like everyone on your team needs to work together to collaborate. This is that staging environment. The second kind of use case would be, let's say you're trying to do integration testing, right? You want to be able to stand up these environments for the duration of a testing suite. Well, that's what Harbor does as well. And all of this runs on our hosted infrastructure because turns out getting these very complicated testnets to stand up really reliably and quickly, well, that's a pretty hard job. So we do a ton of work behind the scenes to really optimize the infra for these testnets. So given that, like, what are these use cases, right? I mean, what would people even use Harbor for? So when we started this company, I think we thought about three primary use cases. The first is when you're experimenting or prototyping with a protocol. The second is when you're trying to onboard users onto your own protocol. And the third is when you're trying to run like full integration tests, right? So let's talk through each one of these use cases. And I'm gonna make it pretty like relevant to Axelar, right? So let's say today you wanted to go and get your feet wet working with the Axelar protocol. What are your options? Well, your first option is you go to the public testnet and then you just execute some transactions. The problem here is that it's a public resource. So you don't know when some dude is going to just mint like 20 million NFTs on the Gurley testnet and you can't do anything, right? So that's problem number one. You could also just go and use Axelar's hosted sandbox. But again, again, public resource. It's not the most reliable thing. I mean, in fact, 2 to 3 weeks ago, one of my engineers actually broke the sandbox by mistake while we were doing stuff for this talk. And essentially it was broken for everyone else on the planet, right? So you can't necessarily rely on like public resources when you're trying to prototype. The third thing that you could do, and honestly Axelar is pretty great about this, is you can like set up a local environment, right? Which is sort of what their DevRel team has been talking about. The problem though is like, number one, you've got to set it up. But number two, it's not really going to be a staging environment, right? Because you need something that is going to be realistic and remote so that multiple people can work together. It's all the classic stuff that we sort of expect in Web 2. What's the second kind of use case? Well, I know like, maybe there's a bunch of people in this conference that are essentially in this ideologically around crypto. I also know there are a lot of people in this conference that are trying to build applications that get usage. And like the fact of the matter is we're in a bear market. So every single point of friction when you're trying to onboard a user or like a customer for your development toolkit, well, that means they're likely going to drop off, right? So today, if you're going to work with public testnets and your user comes in and he or she can't get any Goerli test ether, they're likely just dropping off. Like they're not going to tell you and write a nice email telling you why they didn't use your application, right? And similarly, if you're trying to build a dev tool. So an example of Harbor here would be you could literally just define your own protocol, drop it into your documentation, and then your users can press a button and they have a private version of your protocol that they can play with, they can work with, they can break. So this right here is an example of what that could potentially look like in the Axelar case, right? You simply go to the Axelar documentation, you press a button, and you have your own Axelar testnet ready to go. Now, the final use case is actually integration testing, right? When you're working with other protocols or you're working with distributed systems, the problems happen when you're trying to integrate with these things, right? Like unit tests are great, but really you're dealing with complicated systems. So you should be really running good integration tests, right? For example, I'm making an assumption about my stablecoin on Uniswap. What happens if the price of my stablecoin goes to 0 in 20 minutes? Is my protocol still protected? Like, this sounds like a joke, but this literally happened like 8 months ago, right? So it's not so crazy to have to defensively test against some of these scenarios. So Harbor makes it really easy to write these integration tests, and I'm going to be talking about this in the demo today. So at the end of the day, who can actually use Harbor? Well, today we support 2 testnets or 2 bridges that are on our protocol or on our environment, Axelar and Connext. We're also loading up all of these other protocols. So if you wanted to integrate with Uniswap, in a couple of weeks, you'll be able to do so. Press a button, have your own version of Uniswap, set the state of Uniswap so your in-tech tests are more robust. But essentially, if you're somebody working with other protocols, or you're someone that has a lot of off-chain actors, you could leverage Harbor in order to provide environments, but also provide more robust integration tests. So this is kind of like the presentation part of the presentation. What I wanted to do next was go through an actual demo where we're going to write a test that protects users against a very specific problem that people face when they're trying to leverage Axelar today. So, feel free to follow along. You guys can go over to goharbor.com/interop, and essentially you can clone the repository and write the test with me if you want. Okay, so when we kind of thought about this demo, right? We were sitting around and we were going like, what's an actual real world use case? What would people actually hit? So we talked to Sergey, we sat in the Axelar Discord, we went through the docs, and essentially one of the main problems that users today are facing when they're working with Axelar are these 2 errors, right? Like you're doing general message passing and you have insufficient gas to execute the transaction, or there's some sort of error in your destination contract logic. And if you go to the Axelar Discord, you see this all the time. Like people are always hitting this problem. So we're going to use Harbor to write a test so that we will essentially prevent the second from happening before it goes into your development or main branch. Okay, so suppose you have this problem today, right? You've deployed a smart contract and you're making a GMP call across the bridge. You face this issue, like how do you actually diagnose it? Today what happens is you essentially go to the Axelar scan website and you kind of you wait for the transaction, and then once that's done, you basically load it up into Tenderly, and you kind of screw around with it, you find the issue, and then you fix it. Now this is great, right? Like this is super dope if you want to actually diagnose this problem. But the real fix has got to be a test, right? Because what is the canonical situation here? You have a team. The team is distributed. Everyone's super under pressure because they've got to go ship something, right? And someone somewhere makes a mistake on one of the destination contracts. Ideally, you want a test that will prevent merge, right? And you want to make sure that you're catching these bugs earlier and earlier in the dev cycle. So that's what we're going to do today. We're going to write a test that does exactly what I just said. So go over to the interop kind of the Harbor interop workshop website. You can just go to goharbor.com/interop, and let me just kind of open it up. Once you clone the repository, obviously run yarn install, run npm install, whatever kind of I guess whatever package manager you want to go. This is going to take a little time to run. But once it finishes, I'll start going through what are the exact use cases or the developer experience of writing writing a test that works across a bridge, right? Okay, so this is done. The next thing is compile your contracts. So leverage Foundry, leverage some nice bespoke thing, leverage hard hat, we don't care. We just need the contracts to be compiled. After this, open up the config.js. Every Harbor testnet has a testnet name. And then on line 4, just put in the testnet name that you want your testnet to have. Oops, sorry. Okay, so here, this is the first interaction that we're going to have with the actual Harbor tool, right? So what I'm going to do is first run this. And I want to emphasize how easy it is to get started using Harbor. All you really need is basically a config, which is like a JSON object, and I'll walk through it. And you just need to call .apply. And it works exactly the same as Terraform, right? You declare the testnet, and then a few minutes later, it exists. So let's go through this config. What am I saying here? I'm essentially saying, hey, Harbor, give me a testnet that has a bridge, Axelar. This Axelar bridge should span Ethereum and Polygon. Also give me an Ethereum chain and a Polygon chain. In the Ethereum chain, deploy for me all of the artifacts that are sitting in this file path and deploy them using the deployment scripts that are defined here. Also, give for me the environment variables, Axelar gateway address and Axelar gas receiver address, which are the addresses of the smart contracts that are going to be deployed by Axelar, right, on each chain. Now, let's also go through and look at these contracts, right? So open up message sender. Now, if you guys were in the talks earlier today, this is a classic way that people integrate with Axelar, right? You have one contract on the Ethereum chain. It implements the Axelar executable interface, and it calls the gateway contracts. As you can see in line kind of 36, there is a lot of lag, unfortunately, in this setup, so apologies for that. The second kind of function that this contract also implements is the execute function. Now, if this would, for the love of God, actually scroll down, I could show you guys the execute function. But at a high level, the execute function essentially emits this executed event and does some logic, right? And like the Axelar testnet is essentially listening for this particular executed event. Now, if I go over to the Polygon side, if I go to the message receiver contract, it's kind of more of the same, right? You're just doing some basic stuff. All of this exists in the Axelar local examples repositories. You can just clone that as well. Now, moving over to the deployment scripts, these are also, the same as hard hat deploy scripts. Like, there's no change required, because if you're building a cross-chain application, you're likely leveraging hard hat deploy, because you need a Turing-complete programming language that works outside of the EVM. So this is really standard. All it's doing is deploying the contract on F. Similarly, same thing for the Polygon side, right? So here we have the same hard hat deploy scripts as well. Now, you can also start a testnet with Harbor via the UI. So suppose you just wanted to go and play around with it, right? So here, for example, is the Axelar testnet that you can stand. So you can press a button. Ethereum will have all of these smart contracts loaded up, which are all of the contracts that you need to have your own Axelar testnet. Polygon has all of the same stuff as well. And on top of that, you have an off-chain actor, which is sitting down here. That's essentially the relayer, right? Hang on. Okay, so shifting back, right? You can now this apply testnet is run. We've got essentially a testnet. We've got smart contract A on chain A. We've got Axelar in the middle, and we've got smart contract B on chain B. So the next thing we're going to do is go over to execute cross-chain call. This is going to actually execute a cross-chain message, right? And basically, if you're looking through this, all we do here is we essentially just instantiate a ethers.contract instance, and we call set remote value, right? And we're essentially telling our protocol, hey man, pass over this message. In this case, the message is a custom value, Harbor Workshop at interop. And what we're doing here is we're essentially saying what is the value initially on the Polygon contract, and it should ideally be set to this message, and we're console logging it out. As you can see, something's up, right? Like the message hasn't passed. So what do we do? So we have to diagnose all parts of this transfer. We have to first look at the Ethereum logs, then the Polygon logs, and then potentially the logs in the relayer in the middle. So if you open diagnosis.js, this is exactly what we're going to do. So here, what I'm doing is I'm taking the Harbor SDK, I'm instantiating a version of the SDK, and then after that, I get out my own version of the testnet, and then I pull out the Ethereum logs, and I essentially go through and I print them all. Now, this takes like a couple of seconds to run, but as you can see here, right, like the actual eth call happened. On top of that, you can see that there are a number of contracts that were essentially deployed. So we are actually dealing with a proper Axelar testnet. Like, this isn't a fake. This is a real testnet. But like the thing is, we don't really see a lot of like errors. So the problem is potentially not on the Ethereum side. Okay, let's keep going. So now what we're going to do next is basically do the same thing for the Polygon side, right? And we're going to try and print out all of the Polygon logs. Now, as you can see here, the error is pretty apparent. It's actually, I mean, it's a bit hard to scroll up. I think the system is pretty laggy, but you can see that the error is actually happening on message receiver.sol line 30, right? So now we know where the error actually is. So you can see it right here. So the nice thing about all of this is all programmatic, right? So this is actually a test that you can write. Okay, so now let's go make the fix, right? So we got to open up the Polygon contract, message receiver.sol. Then we've got to go to line 30. And we can see, like, this is just a pretty obvious bug, right? Someone on the other side of the planet was super tired, shipping really late. They pushed this in by mistake, right? They're bad. So let's go fix this testnet. All we have to do is just remove the erroring line and then recompile our smart contracts. Okay, so now we have like a testnet, and the testnet is essentially broken. And we want to basically write a test that will tell us, that will prove to us this negative case. Similarly, we also want a positive case as well, right? Because we want to prove to ourselves that we've actually fixed the problem. So what we're going to do is we are going to go over to the test. And then the first thing we're going to do is basically just recreate another testnet with the fix. So in order to do that, just comment out lines 30 and comment in line 32, right? And then after this, on a new terminal, just run yarn jest test/test cross-chain call.test.js. And we really should have renamed that. That's a lot of tests in a thing. My bad. But while this is running, so I'm now going to let the fixed testnet run, right? And note that we're essentially doing .apply here, so we have our own version of the testnet that is going to stand up at the beginning of this testing suite. So it's a completely clean slate with which you can run your assertions. Okay, so let's now go back and let's actually go through writing the test for the negative case. Maybe let me go through this and then we'll do some Q&A, but I appreciate it. Okay, so let's do the test, right? So here, we're now running this test. The first thing that I want you guys to see is console logging out like the SDK, right? Because the SDK that we put actually makes writing these cross-chain tests really easy. So in this case, you're pulling out Ethereum. Ethereum we give you the wallets, the contracts, the logs, and the endpoint, right? So this is basically all of the information you need to write any assertion that you have. So let's keep going, right? So what we're doing on line 62 here is we're basically taking out the Ethereum contracts on line 54, and then we're just console logging them. And so this is the object that is produced. Here you can see that you have the address. You also have some conveniences, like you have the balances, because you're likely going to be asserting on balances, right, when you're writing any one of these tests. You also have the ABI as well. So the nice thing about this is there's no local dependency. If you wanted to write a test against Axelar today, you likely need, in your own private environment, you likely need the Axelar smart contract artifacts sitting locally in order to be able to interact with them. That then takes you down this big hole of like compiling them and then understanding them. You shouldn't have to do any of that, right? Instead, we just give you the ABI, give you the address, and then you can just leverage the provider, the normal providers that you use in order to run and write your tests. So it's all of the same. Now here, as you can see, like we're just leveraging the exact same kind of experience that you guys would normally use when you're working with others.js. So there's no real switching cost here. And so yeah, let's let this test run. And as you can see here, like it's failing, right? Because this is the broken testnet that we were talking about before. So now we've successfully created a failing example for this particular case. Now, while the other test is running, I also want to go through a couple of other things, right? The first is, it's all well and good to write a test, but how does this actually work within a CI/CD pipeline? Because that's really where it should be running to prevent you from putting in errors. So the workflow file for this is really simple. It's essentially the same as running any kind of jest test, right? Because if you really think about it, we didn't do anything special. All we did was we leveraged an SDK and we wrote like a normal unit test. And that unit test just happened to look, we wrote an integration test, and the test happened to look a lot like a unit test that we would normally write, right? So the experience of writing a multi-system test just got a lot easier. You can also do a few other things in terms of our config. So let's say that you have like a fairly complicated protocol, right? And a lot of protocols that aren't just like thin wrappers on like some smart contract are like this, right? Like you have a relayer, you have an indexer, you have bots, because all that matters, right? These are essentially off-chain actors. You want to be able to stress test this protocol in different kind of scenarios, right? So in this case, what we're doing is I'm saying, hey, give me these two chains, but also give me 2 instances of IPFS, also give me Postgres, and give me like Redis cache as well. It's down there at the bottom, right? And so you can essentially, if you're working on anything off-chain, you can easily run your tests or write your tests against these environments. Similarly, on the, we also make it pretty easy to kind of get, we also make it super easy to define kind of like wallets. So like another example, within the configuration, you can define testnet tokens. So let's say you wanted an Ethereum chain with 3 wallets. Each wallet has 10,000 DAI, OP, and USDC. All you have to do is actually, all you have to do is actually just declare it, and then it'll exist within the testnet as well. But at the end of the day, what I'm trying to show is like there's a better way to write these tests, right? You can write integration tests, and you should write them. And we should be like shifting left as an industry, our dev practices, so that we catch a lot of these problems earlier and earlier in the dev cycle. So just as a summary, right? Like, what did I talk about in this presentation? 1, what is Harbor? 2, what are its use cases? 3, who can use it? And then we went through a demo where we basically walked through how to write an integration test with Harbor. This is kind of like the main meat of what I wanted to go through today. So I've got 3.5 minutes. I'd love to take any questions. I know you had one, so yeah, please hit me up with any questions. Really happy to answer anything.
No, I forgot it.
Do you plan to add support for like Foundry?
I can't hear you, man. Sorry.
Do you plan to add support for Foundry?
Yeah. It's trivial for us, right? Basically, think of us as just like a really good DevOps layer, and like we do hard hat now, but putting in Foundry is just like super easy for us. And then on the Axelar side as well, this is currently a single node relayer. In about a week, we're going to have like a multi-node relayer in the middle. So you can essentially say, give me an Axelar testnet with 15 validators in the middle, right? Because I want to know what happens if that network is congested. Is my UI actually robust to this?
Thank you.
So wait, how soon do you think you'd have the across protocol, like the relayers there, or like UMA relayers? Is there any like how soon do you think you'd have those out?
Could you just repeat the last part?
Like how soon do you think would have those integrated?
Yeah. So we're trying to get to. So I think in the next couple of weeks we're going to load up Layer 0, Uniswap. I think we're going to do Hop. We're just going to go through and hit all the bridges and like a couple of the larger protocols. I think one of the things that we're probably going to do as well is put up oracles, because you're going to want to work with oracles and set the state of those oracles pretty easily, just to defend your, because you can't rely on like Chainlink to always be correct. You also don't know what would happen if someone does like an oracle attack, right? So this is an example of a sort of test that you could now write that you couldn't write before.
is there any way to have like a custom relayer, like one that you have with your own listening to something, listening to events, still talk to the blockchain layers that you have running?
Yeah, you could write your own custom relayer. You just have to give us like a Docker file, and basically everything else we wire up for you.
Okay. And then last question.
Yeah.
In terms of like the Uniswap case, couldn't you just take the smart contracts for Uniswap and then have them locally in the case that you guys don't have them now?
It could, but like I mean, I don't know if anybody else faces this, but the last time I tried working with Uniswap and I tried to set the state, like honestly speaking, I had to go understand the internals of the Uniswap protocol. And I as a software engineer, I think that experience is kind of just broken, right? Like, why should I understand the internals of another protocol to be able to use it? So I think with Harbor, the way it should work is declare Uniswap at this state, write my tests against it, tear down the environment, right? I shouldn't have to know about cast, like the different storage variables or whatever, which is what I'm being forced to do today as a developer.
Anybody else? I got another question.
Are there other questions? He's got a question.
Thanks. Are you building support for Cosmos chains and relaying between them?
Yeah, dude. So this is super. The history behind this is like when I was first building a bridge, I was building on Cosmos, and I was like, how do I have a production-ready staging environment for Cosmos? So right now with Axelar, we essentially have like the Cosmos chain, like it exists, right? So the next thing that we're gonna have to do is basically just expose it in that config. And so it should be able to work. So you essentially give us the node binary, right? Maybe it could be Dockerized, it doesn't have to be. Tell us the number of replicas you want, and then we'll do the rest of the wiring up for you. So you can have a 5-node validator set, 15-node validator set, but it's entirely up to you how big you want it. I think maybe we're at the end. So like, this is who we are. I'm Prakash. My colleague Mani is also in the crowd somewhere. Feel free to join our Telegram. We're happy to work with devs. We think it's a pretty interesting problem. Or you can follow us on Go Harbor HQ on Twitter, and then also just like go hit the website, right? Like hit it, give us your feedback. We're really open to it. And again, I thank you so much for taking the time to listen to me. I really appreciate it. Thanks a lot, guys.